Hey guys, Dr. Brown here, and tonight we have a 4th through 6th grade international challenge problem. This problem is, well, if you're in high school, junior high, high school, college, you should watch this. This is, I just can't imagine when I was in 5th grade, which I pulled this out of a 5th grade book, I couldn't imagine me working this problem. So any of you 4th through 6th graders that can do this, hey, you keep studying your math because you've got some skills, okay? All right, now the rest of you should be able to do this, okay, if you're older, but hey, it's a challenge. Oh, and by the way, I had a comment that said I look 70 years old. What is that? It must be the lights, although I'm only 64, okay. All right, the ratio, here's our problem. Here's the items that are given. The ratio of the number of cows. Now, I grew up on a farm, so I think this one's cool. I should have changed it to pigs because we grew pigs. Okay, the ratio of the number of cows to the number of sheep in farm X. So there's two farms, X and Y. But the ratio of the number of cows to the number of sheep in farm X is 2 to 1. So we've got farm X here. We've got X. We've got cows, sheep, and total. And they're 2 to 1. The cows to sheep. Okay? Now in farm Y, it's 3 to 1. So we've got Y. It's 3 to 1. So we have cows, sheep, and total. It says here that farm Y has twice as many total animals than farm X. So this farm has twice the total animals as this farm. Okay? Now this is where it gets crazy. Okay? When 56 sheep are transferred from farm Y to farm X, so they're going to take 56 sheep from this farm to that farm. It says the number of sheep in farm Y is 7/8 of the number of sheep in farm X. Okay, after all of that, sheep this and sheep that, sheep, 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 what's required is how many cows are there in farm Y? How many cows right there? That's what they want to know. Now I would encourage you, pause the video or back it up and listen to this again, or just pause it and read that problem. Because just to be honest with you, it took me a little bit of time to figure out what exactly are they asking, X and Y and all of that. And that's why I've written it down here. All right, so pause the video, reread, and when you come back, hey, I'll be here. All right, I'm going to make believe you have paused the video and you've worked this out, and now you're just seeing if I can get him. Oh, challenge. All right. Think about 2 to 1. Let's just work at farm X here. And I may be off the screen just a little bit. Sorry for that. But the problem took so much space. I'm over here. But since I look 70 to whoever told me that, I'll be over here. It may help. All right, if I have one sheep, what do I have? 2 cows. So what total? 3. If I have 2 sheep, 2 times 2 is 4. I have 4 cows. 4 plus 2 is 6. If I have 3 sheep, okay, 3 times 2 is 6. 6 plus 3 is 9. Now you'll notice the total is increasing by 3 each time. Critical thing to keep in mind. So every time this is going with a multiple of 3. Now then, this one, if I have 1 sheep, the ratio of cows to sheep is 3 to 1. So if I have 1 sheep, I have 3 cows. 3 plus 1 is 4. And by the way, us going through this analysis, there may be 2 critical thought processes that occur. This is one of them. Okay, what we're doing here is trying to understand the relationship between these animals in one farm versus the other. Because currently, what we have is the ratio of cows to sheep in that farm and the ratio of cows to sheep in this farm. Now later, once we transfer them, we're going to know the relationship between the two. But what I'm trying to do now is see if there's a pattern or something that I can understand the relationship between sheep on this farm and sheep on that farm, because if I can do that, I can link the two together. That's my thinking, okay? All right, so what if I have 2 sheep? I have 2 times 3 is 6, 6 plus 2 is 8. If I have 3 sheep, 3 times 3 is 9, 9 plus 3 is 12. Now you'll notice these are going up. The difference between 4 and 8 is 4. Difference between 8 and 12 is 4. These are increasing 3 at a time. These are increasing 4 at a time. Now you've studied least common multiples, so one would think because of item B here, this farm has twice as many total animals as this one. I can't have, okay, if I have 8 total animals here, that means they have 4. Well, there's no 4 in here. So I need to understand the least common multiple between 3 and 4. Now we know that's 12, but let's go ahead and work it out. So if I start with 2, 4 divided by 2 is 2, bring the 3 down. I'll stay with the 2, bring the 3 down. 2 divided by 2 is 1. Okay, start with the 3. 3 divided by 3 is 1. Drop the 1. I always bring the 1 over. The reason I do that is because when you study greatest common multiples, when you study that, then if you don't have that 1 over here, if 1 happens to be the greatest common multiple, then it's a problem. You'll miss it. Actually, that was the reason I started putting it over here, is because the local student, if the greatest common multiple was 1, say I had a couple of prime numbers or something, they would miss it. So I started, let's do everything over here. All right, 2 times 2 is 4, 4 times 3 is 12, 12 times 1 is 12. So my least common multiple is 12. What does that mean? Well, 12, 24, 36, 48. That's my options here. Okay? All right, so what does that mean here? If I had 24 animals on farm Y, 24 divided by 4 is what? Well, it's 6. 6 times 3 is 18. So I have 18 plus 6 is 24. I have 18 cows, 6 sheep. My total animals is 24. This farm would have 12 total animals, which is half, because farm Y has twice as many as this farm. 2 times 12 is 24. Okay? Hold on just a minute. I have something popped up on my computer I need to get rid of here. Okay. All right, so if I have 12, 12 divided by 3 is 4. 4 times 2 is 8. 8 plus 4 is 12. So I have 8 cows, 4 sheep. Okay. Let's just jump down here to 48. All right, 48 divided by 4, 12, 24, 36, 48. So that would be 12. 12 times 3 is 36. 36 plus 12 is 48. Half of 48 is 24. 24 divided by 3 is 8. 8 times 2 is 16. So I have 16 cows, 8 sheep, total of 24 animals. Twice that number gives me 48. He has 36 cows, 12 sheep. Now, as I mentioned earlier, I was trying to understand, is there any type of relationship between the sheep on farm X and the sheep on farm Y? So I said, well, what's the ratio of sheep on X, sheep on farm X, and we'll call that originally, because we're going to transfer some later. That'll be the final number. We'll have an F there. So sheep on X as a ratio of sheep on Y originally equals 4 to 6. Well, what is 4? It's 2 times 2. 6 is 2 times 3. The 2's cancel. I end up with a ratio of 2 over 3. That's the ratio of sheep on X, farm X, to sheep on farm Y. Originally, as stated in the problem right now before we transfer. Well, what happens if they have a bunch more animals here? Now I have the ratio of sheep on X to sheep on Y is 8 over 12. Well, what is 8? That's 2 times 4. What is 12? It's 3 times 4. Okay, the 4's cancel. 2 over 3. Hey, how about that? So what does that mean? The ratio here, sheep on X, the original number that I have, divided, or as a ratio of sheep on farm Y, is equal to 2 over 3. So if I cross multiply that, 3 times the sheep on X, farm X originally, equals 2 times the sheep on Y originally. If I divide both sides by 3, I end up with the sheep on farm X is 2/3 the sheep on Y. Can you see that? My pen's just about to play out, it looks like. Sorry for that. Okay. I'm going to write that up here. Hopefully this is a better pen, better marker. All right, so the sheep, oh yeah, that's a good one. Sheep on farm X originally, that's why the little O, equals 2/3 the sheep on Y originally, or initially. They don't use an I, by the way, as a subscript because it's used as an indexing term, and you'll learn about that later. Okay, so we've just developed, and I've just marked through it, 2/3. So the sheep on X, farm X, is 2/3 the sheep on Y as originally stated in the problem. Okay, I'm going to erase everything here that we've done so far, because we've got to expand our thinking here. This is a fantastic problem for young people to really think. All right. Now then, now that we've established there is a relationship between sheep on this farm and sheep on that farm originally, now then, when 56 sheep are transferred from farm Y, so they're going to take 56 sheep from here to there. And that's going to give me then, and they're saying the sheep on farm Y is 7/8 of the sheep on farm X. The number of sheep in farm Y. So the sheep in Y final is 7/8 the sheep in farm X final. Now the reason I put an F, it's different than the original number. Well, what would the sheep on Y be? I think I'll put that here. Sheep on Y final would equal my original number of sheep I had minus 56. So it's the sheep on Y originally minus 56. Well, what's the sheep on X final? It's going to be the original number on X plus 56. So you can already see I can substitute this for sheep on Y final. Let's just do that. I have sheep on Y final, which is the sheep on Y original, minus 56, and that equals 7/8 times sheep on X final, which is sheep on X original plus 56. Wow. What to do now? Well, we've studied in the past how to get rid of fractions. I can just multiply both sides by 8. If I multiply this times 8, that 8 cancels. So I end up with 8. Well, I'll just let it cancel it. Okay, we'll just save some space here. So I end up with that. 7 times this parentheses, and then 8 times that one. Well, you'll notice I have two different variables here and one equation. So I have an equation I've written up here earlier that says the sheep on X originally is 2/3 the sheep on Y originally. So I can substitute for this right here. So that would give me 7 times 2/3 the sheep on Y originally plus 56. And that equals, I'll go ahead and multiply this out. This is 8 sheep on Y originally minus 8 times 56. And that equals 7 times 2/3 plus 7 times 56. All I've done is multiplied that 7 by what was in the parentheses after I made that substitution. Well, what does that give me here? 7 times 2/3 is 14/3. The sheep that's on Y originally plus 7 times 56. All right, well, let's see. 8 times sheep on Y originally minus 8 times 56. All right, that's what we have at the moment. Got another pop-up on my screen here. Excuse me. All right. What I'm going to do now is I'm going to add 8 times 56 to both sides. All right, so I have 8 times the sheep that's on Y originally minus 8 times 56 plus 8 times 56 equals 14/3 times sheep on Y originally plus 7 times 56. Now I added 8 times 56, so I have to add 8 times 56 here. All right, so a negative 8 times 56 and a positive. If you have a number line, you have, say, a negative 2, and you add 2 to it, add a positive 2, you go back that direction, you end up at 0. Same, if I had a minus billion plus a billion, it's still 0. So these two numbers canceled each other. And I end up with 8 times the sheep that's on Y initially, farm Y, and that equals, you haven't learned factoring yet, but if you have a 56 in both of these, and you can factor that like that. You have learned the distributive rule. That's 56 times 7 plus 56 times 8, which is what that is right there. So it ends up being 56 times 15. So let's work that out right here. 56 times 15, 5 times 6 is 30. Carry the 3. 5 times 5 is 25, plus 3 is 28. Throw in a 0. 1 times 6 is 6. 1 times 5 is 5. 0 plus 0 is 0. 8 plus 6 is 14. Carry the 1. 5 plus 2 plus 1 is 8. So that's 840. So we have 14 over 3 times the sheep that's on farm Y originally, plus 840. Whoa, this is coming along. Well, now I have this 3 I need to do something with. All right, let's just go ahead and do this. Let me just subtract 14 over 3 from both sides. Matter of fact, let me move this 8 over. 8, that is sheep on Y0, minus 14 over 3 sheep on farm Y originally, minus 14 over 3 times the sheep on farm Y. So this and this cancel. So now I have this guy here, and I need to get a common denominator so I can add those together. So obviously, if that were a 3 underneath, I'd have to multiply this by 3 over 3, which is 1, because that's 8 over 1. And what do? If you think you have this correct, if you'll multiply this number by 1, but start by multiplying what you think the denominator is. 3 times 1 is 3. And then you say, okay, that's correct. Then multiply the numerator together. I've seen many students, well, I want to multiply this by 2 over 2. That's 1. Well, that is correct. It is. But 2 times 1 is 2, not 3, not your common denominator you're trying to get. So before you make the mistake, install a little check here before you do anything. Now, 3 times 8 is 24. So I have 24 sheep on Y0, Y initially, minus, this is already 14 over 3, so sheep on Y0. And that equals 840. And you're probably thinking, well, we're not there yet. Okay. Why don't I just multiply both sides by 3? And 3 over 3 gets rid of that 3. Okay, so now 24, I only have the numerator left, and we're running out of room here. Matter of fact, let's put this up here. We have 24 sheep on farm Y initially, minus 14 sheep on Y originally, and that equals 840 times 3. Well, 24 of something minus 14 of something gives me 10 of something. In this case, my something is sheep on farm Y originally. And that equals 840 times 3. 840 times 3. 3 times 0 is 0. 3 times 4 is 12. Carry the 1. 24, 25. It equals 2520. Divide both sides by 10. 10 divided by 10 is 1. If you say 0, no supper for you. Okay, so 1 times the sheep on farm Y initially at original time equals this over 10, which is 252 sheep is what I had. The sheep, already got a sheep here. Sheep on farm Y originally was 252. Now you might be thinking, but not yet. That's sheep. What are we required to get? Well, how many cows are on that farm? This is like whale blubber. The more we chew it, the bigger it gets. No, but we're almost there. Almost. All right, how many cows are on the farm? Well, what did we have before? We had cows to sheep. That was a ratio of 3 to 1, right? All right, so cows to sheep was 3 to 1. Cows to sheep is 3 to 1. Well, I have 252. So now if we cross multiply, and we're just about running out of room here. Something's got to go. So cows times 1 equals 3 times 252. So 3 times 252 times 3, 3 times 2 is 6. 3 times 5 is 15, carry the 1, 3 times 2 is 6, and 1 is 7. So the cows on farm Y is 756. Now you can go, but how do we know that's correct? All right, let's just take a snapshot there. I wish I had a bigger board and a longer cord, I guess. All right, so we've got cows. These got 756. We had 252 sheep. What does that add up to be? 756 and 252 would give us our total animals, right? So we have 8, 5 plus 5 is 10, carry the 1, 7 plus 3 is 10. So we had 1,008 total animals. Now, if we take that number, now this was the original numbers before we transferred the 56. Because remember, that's why I set it up where we had the sheep on farm Y originally. That's why we had the difference between original numbers and final numbers. Finals was after the transfer. All right, I'm going to erase this here. Give us a spot to work. And let's validate if in fact we're correct. I think I'll just get all of this. Will get us a bigger spot. Okay, if this is 1,008 and it's twice the size of the total in farm X, we should be able to divide that number by 2. 118 divided by 2. 2, 5 will go into that at 10. That's 0. Bring down a 0. 2 won't go into that. Bring down to 8. 2 will go into 8 4 times. 4 times 2 is 8. Minus 8, 0. So 504 is the total. Well, how many sheep would that be? Remember, these grew by a multiple of 3. These grew by a multiple of 4. So we take 504 and divide it by 3. 3 going to 5 one time. 26 times 3 is 18. 20 minus 18 is 2. Bring down the 4. 8 times 3 is 24. And that gives me 0. So he had 168 sheep. Now if we multiply that by 2, we'd get the number of cows. But we don't have to know the number of cows. Because what's going to happen now is we're going to transfer 56 of those over to here. Remember, that was our number. The sheep on Y originally minus 56 gave me the sheep on Y final. The sheep on X initially, which was 168, plus the 56 we transferred is going to give us that number. The ratio of this number to that number should be 7 over 8. Before we do this, what is 7 over 8? It's 0.875, but let's figure that out. 7 divided by 8. And we could do this in several different ways, but where's my decimal points? Right there. Will 7 go into 8? No. So add a 0. Will 8 go into 70? Yes, 8 times. Now you'll notice I'm on the other side of the decimal point. That's why it's critical when you start this. Where's my decimal? Let me put it up there. Figure out where it is. Now if you're dividing something by 100 or whatever, you may have to manipulate that. In other words, if I had a 0.8 here, I'd have to move that over 1, and then I would put it over there. Okay, but wherever it is, it ends up down here, go ahead and stick it up there before you start. And I don't have to move anything because I'm dividing by a whole number. Okay, 8 times 8 is 64. 4 from 10 is 6. Bring down the 0. 7 times 8 is 56. 6 from 10 leaves me 4. Bring down another 0. 5. 5 times 8 is 40. 40 minus 40 is 0. So my 7 over 8 equals 0.875. Okay. So if we divide, what did they say? The number of sheep in farm Y, the number of sheep in Y final equals 7/8 of the sheep in X, farm X final. And we're about to calculate the final number for farm Y and farm X. Okay, 252 minus 56, that'd be 196, right? Because if that were 52, it'd be 200, and it's 4 more than that, so it gives me 196. So 168 plus 56, 8 plus 6 is 14, and add that to that, it'd be 12. 6 plus 6, 12, plus 1 is 224. Now then, we could take 196 divided by 224, and we should get that right there. That may be a little easier if we said, well, Y final, 196, it should equal 7/8 of 224. So I'm going to take 224 divided by 8, and then whatever that comes out to be, multiply it times 7, and it should give me 196. That might be easier than taking this divided by that. Okay? All right, so 224 divided by 8. 8 times 2 is 16. So that's 4, 5, 6, 64. Bring the 4 down, gives me 64. So 8 times 8, 64. Subtract that, gives me 0. So 28 is my answer there. Now 28 times the 7. So what I did, I just divided this into that, and now I'm multiplying it times 7. So 28 times 7, 7 times 8 is 56, 5. 7 times 2 is 14 plus 5 is 19, 196. 196 is the sheep in Y final. So that tells me that that 7/8 is in fact correct. So how many cows are in farm Y? 756. 756. Wow. Now then, wow. That's a good problem. Okay guys, why are we doing this? You may think we're crazy. No, it's problems like this that you have a few discoveries that challenge you. When we developed this equation, because we thought, wow, we're going to have a relationship of sheep in farm X to Y, and we didn't have that. We had the ratio of sheep in X and the ratio of sheep in Y, and then we determined this equation from looking at observing different numbers along the way. So that allowed us to get this, and then we just simply took this, the sheep final in Y. You know, this was stated in the problem, but it's up to us to read that problem and extract that. So when you see 7/8 or some number of, that means you're multiplying. So what am I multiplying by? Oh, I'm multiplying by the sheep in farm X. But it was the final sheep in farm X after the transfer. And that's why we gave different notation to initial sheep in each farm and final sheep in each farm. Okay, why are we doing this? Together we're trying to build a better tomorrow. I can't overemphasize, if you want to get good in math, practice math. And don't just do things that's easy. Challenge yourself. And this is a good challenge for most students, actually, all up and down through school, much less in elementary school. Whew. All right, guys. That's all for now, and study, and we'll talk to you next time. Thanks.